Hey everyone, in this video we'll answer the question, when you have a redox reaction, how do you tell which atom gets reduced and which atom gets oxidized? First, remember that redox reactions are simply reactions where electrons are transferred from one atom to another. The atom that loses the electrons is being oxidized, the atom that gains electrons is being reduced, like our example with magnesium and oxygen, where magnesium transfers its valence electrons to the oxygen. What we didn't say is how exactly can you tell that the magnesium is the one that loses and the oxygen is the one that gains? Now, before we answer that question specifically, there is a helpful memory tool I'd like everyone to be aware of. And there's a couple of these out there. You may have heard of some different ones. My favorite one is Leo says GER. Leo says GER is an acronym that stands for loss of electrons is the oxidation, gain of electrons is the reduction. It's just a nice, helpful way to always remember that the losing electron atom is the oxidation process and the gaining electron atom is the reduction process. It's also the key idea for this video, so make sure you pause, take a moment, and write that down. So now back to our original question of how can you tell which atom gets oxidized and which atom gets reduced. To see how this works, let's bring back my magnesium and oxygen reaction one last time. You can see all the oxidation numbers are already assigned above each atom in yellow. What you've got to think about is for each individual change. So we'll start with magnesium 0 changing to Mg plus 2. What type of change in electrons would allow magnesium to go from 0 to plus 2? And in this case, what's more important is that it gets more positive. In terms of gaining or losing electrons, the only way that you can get more positive is by losing negative particles. So in this case, losing electrons. If we do the same thing with the oxygen, it goes from 0 to minus 2. It gets more negative. In terms of gaining or losing electrons, the only way that you can get more negative is by gaining electrons. And this is a pattern that you can always look for. One atom should be getting more negative, that's the one that's gaining electrons. The other atom should be getting more positive, and that's the one that's losing electrons. Let's bring back the entire equation and put in our final labels. Remember, magnesium is the one that's losing electrons, so Leo tells me that's the oxidation. Oxygen is the one that's gaining electrons, so GER tells me that's the one that is the reduction. Or we could just put in the labels, magnesium is being oxidized and oxygen is being reduced. Let's take a look at a couple new examples. Here I've got nitrogen reacting with hydrogen to form ammonia NH3. I'm going to start by putting in oxidation numbers above each atom. These are both elements, so they're going to be 0. Know that hydrogen is going to be plus 1, and since there's 3 of them, my nitrogen has to be minus 3, so that these total charges add up to 0. The first thing I notice is that nitrogen goes from 0 to minus 3. It gets more negative. The only way it gets more negative is if it's gaining electrons. And since it's gaining electrons, that means it's being reduced, or it is the reduction process. That means that hydrogen, going from 0 to plus 1, is getting more positive. The only way you get more positive is by losing electrons. This would be the oxidation process. The final labels that we'll include are nitrogen is being reduced and hydrogen is being oxidized. And one final example, this might be a good time to pause the video and see if you can do it yourself before you watch me go over the answers. I'll start off by putting in oxidation numbers. Let's do the easy ones, aluminum and hydrogen, both elements, so both 0. My hydrogen is going to be plus 1 here in this compound, which means chlorine has to be minus 1. Here my aluminum is in an ionic substance, so it's going to have its charge equal to the oxidation number, so plus 3. And the chlorines will again be minus 1 since there's 3 of them to balance out that plus 3. I can see then that the aluminum is the one that gets more positive. The only way you get more positive is by losing electrons, so that's my oxidation from Leo. I can see the hydrogen goes from plus 1 to 0. It doesn't actually get negative, but it does get more negative. That means it's gaining electrons in this case, so it is my reduction. And those final labels, aluminum being oxidized, hydrogen being reduced, and the chlorine is not oxidized or reduced. That concludes this video on which atom gets reduced and which atom gets oxidized. Thanks for watching.